This video was made January 7 of 2013, and is helping the students in my class with their homework. And we are using the data sheet from the lab that we're going to be performing. The lab can be picked up at my website, which is mrwiggerside.com/chem, and going to the Learning Center, and then going to the lab section right here, and going to chapter 10, which is the chapter that goes with this particular activity. And we are going to look at the printout that all my students have to do, which includes how to do the lab, and then secondly, the data sheet that we use for the lab, which has the list of the chemicals that you'll need for this activity. So, what we're doing is mixing chemicals, and this 2 times 3 that you see right here, that 2 times 3 means chemical 2 with chemical 3, which is from the list at the bottom of the sheet you were just looking at. So, what we do when we're writing the skeleton equation, which is the first thing you have to write when you're doing an equation like this, we look and see that this guy is chemical 2 and this guy is chemical 3. So what we do is note that 2 and 3 are coming from that list at the bottom. Now we're going to take iron out of this iron 3 chloride, and we're going to put him over here. That's the first step in all of these. And then we're going to take the metal in the second one, the aluminum, and put him over here. That's the way we start all of these guys. Now we almost have a skeleton equation, except we don't know who's with the iron and the aluminum on the right side. And since this is a double replacement reaction, which is one of the things you need to state for each of the reactions that are being done, we know that this guy, the chlorine, is going to go over here with the iron. And so we're going to put the iron or the chlorine there, and we're going to see what the charge is on the iron in just a moment. I'm not going to do charges yet, but we're going to put the other molecules with these guys. Now, aluminum, instead of having the sulfate, is now going to have the chlorine. And so we put the chlorine. Oh, I just messed up. It's going to have the chlorine. And I should have had sulfate over here with this guy. SO4. Now, let's go ahead and figure out the charges. First, for the iron. Iron on the left side, not on the right. Because once we figure the charge over here, which is what they were originally as the compounds, we will know what the iron is. And iron is going to be a 3+, and we get that from the subscript of the chlorine. Alright, so iron is a 3+ on the right side. He will also be a 3+ on the left side, and here on the right side he's also going to be a 3+. So iron is not going to change his charge, nor will the aluminum. So aluminum is over here, and we see 2 aluminums, and I think I have this formula wrong. Let me check it. I was right. I did have it wrong, so it's corrected now. So this is aluminum with sulfate, and there's 2 aluminums and 3 sulfates. So I look at this subscript right here, and that's going to give me the charge on aluminum. We could also figure aluminum as 3 because he is in column 3 on the periodic chart, and that would give him an automatic 3+. So charges don't change as we go from one side to the other. And this guy is a 3+. So Now we have to look and see what are the subscripts going to be for the molecules on this side. First of all, for the sulfate and the iron, and then for the aluminum and the chloride. So let's start with the iron. Iron is a 3+, and I'm going to write this charge in sulfate. You should know this because this is on the Memorize Ions chart. And these guys, the charges here, are going to be used to figure out the subscripts for the ions that are below them. So the iron is going to have a subscript of 2, and sulfate here is going to have a subscript of 3. And that makes everything work to balance out that molecule. Now we go over here to the aluminum chloride. We know aluminum is a 3. We know that chloride is a 1-, and we get that right off the chart. Because chlorine is in column 17 or 7, depending on what chart you have, and his charge is always going to be a -1. So the subscript for aluminum is 1, and we don't need to put it there because it's assumed to be 1 if we don't have a subscript. And so the chlorine now is going to get the subscript of 3. And we have put the molecules together properly now on the right side so that the total of the charges for the cations, which are these guys, the positive dudes, which always come first, and the anions, here and here, which are the negative guys, that always come second. And now we're ready to go. We've got everything we need to be able to balance the equation. This is now called a skeleton equation, and we're going to balance this guy by, first of all, looking at iron on the left. Iron on the left over here, there's only one of them, but the iron on the right, there's going to be 2 of them. So let's go ahead and put a coefficient here of 2. And this 2 times this little 3 gives us 6 irons and 9 chlorides, which we're going to worry about later. But this 2 and 2 for the iron is already figured out here, so the irons are balanced. Now let's balance the aluminums. We have 2 aluminums here. We're supposed to have 2 aluminums here. So the only way we're going to get 2 aluminums here is with a coefficient at this point. So we put the coefficient here to get our aluminums right. Now let's check out and see what we did to the anions when we balanced the cations. These are the cations, positive. And so 2 times 3 chlorides is 6. Let's see how many chlorides we have over here. 3 times 3 is 9. So that's not going to work too well, is it? Let's see what happened to our sulfates. We have 3 over here, and we have 3 over here. So let's figure out what in the world we did wrong. Well, the error is right here. The aluminum here was 2. The aluminum over here should also be 2. So I messed up there. So let's get that fixed up. And now we have 2 aluminums over here. And now we have 2 aluminums over here. So let's go to the chlorides again. And the chlorides, we have 3 times 2 is 6. And now the chlorides are 2 times 3, which is 6. And the chlorides balanced. So chlorides are balanced, and aluminum and iron are balanced. Let's look at the sulfates. We had 3 sulfates over here, and 3 sulfates over here, and we're good there. So everything is in balance, and all we have to do is put our coefficients in for the ones, and we're done. That is a balanced equation. Okay, one other thing, the chart for telling you how to figure out the type of reaction that you see up in this area here, okay, this guy is going to be on your homework page for tonight. So let's go ahead and go there and show you that homework page. This is the home page on my website. And to get to the homework page, we just go to today's date, which is January 7 of 13. And there is the same chart that you saw in the last slide. So we're all good to see how that went. You'll notice that I have provided for you in this the page numbers in the textbook that refer to how to figure out what these reaction types are. So we're good to go for the next reaction. Okay, this reaction is chemical 2 with chemical 4, and chemical 2 was, so your chemical 1 was iron 3 chloride again and hydrochloric acid. So that's going to be your reaction. We're taking the iron from here and putting him over here. We're taking the hydrogen from here and putting him over here. Notice we always put the positive ion or the cation first when we go to the other side. And now we're going to go ahead and figure out the charges. Well, nothing has changed with iron 3 chloride. He's a 3+. Again, we know that because of the subscript on the chloride. And we know the chloride is a 1- because that's the subscript on the iron. Now let's go over and take that charge to the other side, because that won't change on the other side. And then we're going to use the hydrogen. He is a 1 over here. He's going to be a 1 over here because he's with chloride, which is a 1-, and he'll be a 1+. So we'll put his 1+ here, and he's also a 1+ over here. And now we're ready to figure out who's going to be with who on the other side. Well, the chloride over here can't be with iron on the other side because they've got to switch partners. So the chloride is going to wind up with the hydrogen. So we're going to put the chloride here, and then we're going to put the, whoops, not there. Oh my, no. Chloride goes right over here with the iron. Okay, and then the chloride, yeah, they've got the same thing. Actually, this is going to be a no reaction type of a problem, because as you can see, the numbers are not going to change for the subscripts. You can see the number for iron on the left side here is a 3+, so he's going to be a subscript of 3 on the chloride. And chloride is a 1-, and there's no subscript on iron, just like on the left side. And then this guy is a 1-and-1 relationship also. And so we've got the same reactants and products. Why did that happen? Because chloride was the same for both of the cations. Okay, chlorine was the anion for both of these. And so on the other side, nothing's going to happen. And so this is going to be a no reaction thing. No reaction is going to happen with this because everybody's got what they had at the beginning. All right, let's go down here and let's work on our next equation. So if you like, you could go ahead and put 1 coefficients. Notice I just put these guys in for everything because nothing's changing, and our coefficients are 1, 1, 1, 1. So let's go ahead and start with our next equation. For this guy, we'll get the charges again first. Iron is a 3+ still, because we have the coefficient of 3 on the chloride next to him. And manganese, we need to look at him. Now manganese can be more than one charge, so we have to figure out what his charge will be. Now he's with sulfate. The sulfate ion is one of our ions that we memorized. And, whoops, not 3. No, he's going to be a 2-. And manganese then, because there's only one sulfate, see, sulfate is SO4, and he's a 2-, so this guy has to be a 2+. And he has to be a 2+ because that molecule has to come out to a net 0 charge. Now let's go ahead and put the charge on chlorine. Okay. And by the way, these charges are not required when you write equations, but I think for right now, while you're back getting used to this stuff, it doesn't hurt at all to go ahead and put those in. So let's put the 3+ for the iron on the right, and we'll also put the 2+ for the manganese on the right. All right, now let's take chloride here and put him with the iron because we're going to do switch partners. And so we'll have a chlorine here. The only question is how many, which we'll deal with in just a moment. And then the sulfate here is going to wind up over here with, or the chloride here was supposed to end up with the manganese. Boy, I did that again. Let's go ahead and put him over there. And now iron is going to wind up with sulfate on the right side. And so we'll put the sulfate in here. And let's see what the numbers are going to wind up with on the coefficients. Sulfate we know to be a 2 minus. And manganese is a 2 plus, chloride is a 1 minus. So we're going to do the crisscross, and the 3 here is going to become the subscript for the sulfate. Just think of that as absolute value because you don't carry the charges down. Okay, and this guy will be a 3, and then the iron will be a 2, and that 2 for the iron came from the charge from the sulfate. Now manganese, we're only going to have one of him, so we don't need to write his subscript. And the 2 plus here will give us how many chlorines we're going to have. And that's going to be 2. And now we have the molecules made for the right side over here, and we're ready to balance. And at this point in time, we have a double replacement reaction, and the formula that's here, this whole formula now, is our skeleton equation. And we're going to have to balance that skeleton equation now. So let's start out with the irons. The iron here has a 2 subscript. The iron here has no subscript, and so there's only one of these guys, but 2 of them over here. So since we're balancing the equation, we can only deal with coefficients, and we'll put the 2 up here. Let's balance the manganese now. Manganese is 1 over here and 1 over here, so we don't need a coefficient on either side. Okay, but we are going to have a problem with the chlorides. Okay, so we have 2 chlorides over here. We're not going to have a problem at all, are we? But we have a 2 over here to get the irons in balance, so that's going to mess us up. So how are we going to get this thing straightened out? Let's go ahead and balance our manganese chloride with using the chlorines. We'll take the subscript for the iron, we'll take the subscript for the chlorine here and put that as a coefficient here. So that's going to give us 6 chlorines on both left and right. Put that coefficient of 3 there, because 3 times 2 is 6, and 3 times 2 is 6. So our chlorines are balanced. Now, we know that manganese just got a 3 in front of him, but there's no manganese here, nothing but a 1. So we've got to put a 3 out here to balance our manganese. So manganese is 3, manganese here is 3. Sulfate here is 3 because of the coefficient. Sulfate over here is 3. You see, when we balanced our manganese, we also balanced our sulfates, which was nice. You'll see a lot of that in these kinds of equations. And then the iron is 2 over here because of the coefficient, 2 over here because of the subscript. Chlorine is 6 here and 6 here because 2 times 3 is 6 and 3 times 2 is also 6. So we have ourselves a balanced equation, and at this point in time we can go ahead and put in the 1 for the coefficient of the iron to sulfate. So that's your next one. Let's go on to the last one. Okay, this last one I'm going to go really fast. So we know that 3 plus is for the iron. We know that hydrogen, I think I have the wrong reactant. And by the way, this guy on the last page was also a reaction type of double replacement. Now over here we're going to have a double replacement again because we're going to switch partners and dance. And the chloride which you see here, is going to be with the strontium on the other side. So let's go ahead and put them over there. And then the nitrate is going to go with the iron on the other side. And we're going to need more than one of those nitrates, I can tell you that right now. But let's go ahead and finish this guy off. Strontium is always a 2+, and we know that in this particular case if we didn't know anything else, because there's 2 nitrates. 2 minuses have to be balanced by 2 pluses. So each of these guys gives us 1 minus, and there's 2 of them. So that's why this guy is a 1 minus. And this guy is also a 1 minus, and they are the same on the other side. And so let's go ahead and finish this thing off. First of all, we get our subscripts in, and since iron is a 3+, we need 3 nitrates to balance him. Since strontium is a 2+, we need 2 chlorides to balance him, because each chloride is a 1 minus. And then we're going to go ahead and balance. I'll balance the anions first. And so if you look on the right side, on the anions, we have 2 chlorides here, 3 chlorides here. So we're going to do a crisscross. We're going to use this guy for the coefficient here, and let's put him in. We'll use this guy for the coefficient over here to balance that out. And so that guy is a 2. That guy is a 3, I mean. Whoops, that shouldn't have happened. Let's do Control Z, and let's go ahead and pick him up as a 3. And so this 3 came from this chloride, and this 2 came from this chloride. And now we need to balance the nitrates, and the 3 here will be used here, and the 2 here will be used here. So this becomes a 3 and a 2. And we're balanced, and you've seen how this works. Hopefully you should be able to finish the assignment now. Bye-bye.